All right, guys, welcome back to the channel. And if you have been watching, you would have noted I recently posted a video on the rules of the differentiation. So today, what we're going to be doing is we're going to be looking at some of the rules. Specifically, we're going to be doing some of the problem that involves the power rule, quotient, product, and chain rule. So I got the problems right here, and we're going to be working a few of them from each of the section. I think it's about 8 in the first section, probably do about 3. We'll cement the concept for the power rule, and then we're going to move on to using the chain rule and the product rule and the quotient rule. All right, so recall that from the previous video we said that the power rule, d by dx of, let's say, a x of n is equal to n times a x of n minus 1. So you take the exponent down, multiplying it by coefficient out front, and you reduce 1 from the exponent. So that's the power rule of differentiation, okay? So we're just going to do 3 examples from this list right here. And the first one, we did already in the previous video, so we're not going to do that one. That's x squared. We're going to look at the second one here, which says that 3, give me a different color. We have 3x squared plus 2x. And we want to differentiate this thing right here. I'm just rest the paper right here. We want to differentiate this quadratic equation. Well, not equation, expression. Anyways, so if we're going to differentiate this, notice that the terms right here in x, this is x to the second power to the exponent of 2 and x to the exponent of 1, right? So if we're differentiating this, in this case, a would be 3. We still have x, and the exponent here would be n. In this case, a is 2x, and the exponent here is 1. So if we're differentiating this, so d by dx of 3x squared plus 2x, this is equal to, we're taking the exponent down out front, so we're going to do it term by term, right? Because the derivative of the sum is the sum of the derivative, which should be d by dx. So we take the exponent down out front, so it would be 2 times 3x, and we subtract 1 from the exponent, so that's 2 minus 1, and we're adding this one here. We have 1 times 2, because we take the exponent down out front, we're multiplying it by the coefficient here, so that's x, and that's raised to the 1 minus 1. And from here, we can see that this just simplifies to 2 times 3 gives me 6. We have x, and then 2 minus 1 just gives me 1. And we're not going to put that 1 there, because with or without that 1, that exponent is still 1. We're adding to that. 1 times 2 gives me 2. And x to the 1 minus 1 is x to the 0. And that's a property. Any base raised to an exponent of 0 is 1. So that just becomes 2. So our final answer here is 6x plus 2. And we're done. I mean, we could have simpled and factored, but we're not interested in that. We're just taking the derivative and just getting to the answer. We're not going to simplify it as much as possible, because we could take a factor of 2 outside of the parentheses, and then inside you would have 3x plus 1. Okay? Next question. What's the next one on this thing? We have this one right here, says x squared plus x cubed, that is, sorry, x cubed plus 5x plus 12. All right. So we're taking d by dx. So d by dx, so our derivative with respect to x is equal to, let's do this a little bit faster now, so we can pick up the speed. And we might not use these, ideas right here we're just going to look at it until. So we bring the 3 out front. That's 3 times 1. That's still 3. We have x, and we're going to raise that to the 3 minus 1, which is squared. This right here, this is x. You could consider that x to the first power. You bring that 1 out front. 1 times 5 is still 5, so we're adding 5. And we have x to the first power. When we subtract 1 from that exponent, that becomes 0. X to the 0 is just 1. So we just left with 5, because 1 times 5 is still 5. The derivative of a constant, remember we talked about that. The derivative of a constant is just 0, right? So 0 would be the next term that we're adding. So we could put that plus 0, but you're already adding nothing. So we don't have to do that, right? So this is our final answer to this piece right here. We have 3x squared plus 5. And we're just using the power rule in this case. You'd want to think that this could incorporate the power rule as well. Remember, we could say that this is a coefficient of x to the 0, right? And when you subtract 1, right here, doesn't make a difference. It's still going to be 0. If you look at it, we would have 12x to the 0. When you take 0 out front, 0 times whatever you're going to get would still be 0. So that is why we could leave that term out. Okay? Right? Hopefully I don't make any mistake while going through these. Let's go. Moving on. We're going to do one more of the power rule. And I feel as if it's the most straightforward one. So persons might not have any issues with that. Let's look at this one that has an fractional exponent. Same case. So we have 12x squared plus 5x plus 13x to the 5th over 5 plus 12. We got this one right here. All right, so again, we're taking the derivative. I should have started using color codes, but not necessary at this time. So the derivative of the sum is the sum of the derivative. So what we're doing is actually applying the derivative to each of these terms right here. So in the next line, what we're going to have, using green, favorite color, power rule on this thing, 2 times 12, which is 24. We subtract 1 from the exponent, and we're going to left with x to the first power, done. This right here, x, this is x to the first power already, like that. We put that 1 out front. 1 times 5 is still 5. When we subtract 1 from that exponent, 1 minus 1 gives us 0. Any base to a power or exponent of 0 gives me 1, so we're just left with 5. Now this thing right here, if you notice, we have 13x to the 5th over 5. What we can do is to separate that constant term, that coefficient out front, from the variable piece right here, which is x to the 5th. So we could rewrite this as 13 over 5x to the 5th, so that it looks a little bit straightforward. So this 13 over 5 would be our entire coefficient. And no, we're not going to change that to a decimal, because look what happens. When we take 5 out front, we multiply 5 times 13 over 5. You're going to have 13 right here. And then we subtract 1 from the exponent, which is going to give us x to the 4th power. All right? And then we have a constant again. The derivative of a constant, 0. So that just goes to 0. And then we clean this up a bit. Normally, conventionally, when you're writing it, they normally put the term with the highest exponent out front. So we're going to have 13x to the 4th plus 24x plus 5. Because 5 plus 0 is still 5. Those are the constant terms. And that would be our final answer to that one. And we have concluded using the power rule. We're going to move to a different rule. Let's move to a different rule here. Chain rule, which is a nice one. Let's clean this up. So now we're going to be using the chain rule. Chain rule or differentiation. Okay? So we're going to take some few exercises. And again, if I made any mistake, just type it down there in the comments. I'm not looking at the answers at this time. All right. I do have the answer sheet though. I'll check it after. Let's go. Chain rule. We're going to look at these pieces right here. We're going to look at some trig functions. This is nice. This is nice. We have sine of x squared, right? Oh, forgot to write the definition. The definition of the chain rule right here. So the chain rule, remember we're saying that it's a function within a function. So it would look like this, f g of x, and the derivative of that will be, we're taking the derivative of the outside function, so it's f prime of g of x, so leaving the inside function unchanged, and we are adding, not adding, we're multiplying that by the derivative of the inside function, which is g prime of x. So for the first two cases, what I'm going to do is I'm going to identify my function in f function and my g function so that you could see what's really happening with these two things. Because I know the notation sometimes may not be as clear as we want them to be. And so I'm going to be doing that to help us with that. So if you look at this function right here, we have sine of x squared. The sine of theta or of anything is already a function. The argument here inside, or the angle, you could say inside here, which is x squared, right, is also a function in itself. So our f function in this case would be the sine of, let's make x squared, let x squared be equal to v, okay? So we'd say the v, sine of v, that's the f function. So f of x, this is f of x. Let's use purple to identify that. So we're going to say let this be f of x, okay? And then the inside function here, g of x, is x squared. So we're going to make that x squared function, right? Which is v, right? So you see that? What's happening here? V is g of x. Let's put that in purple. So we can make this v also. So make that v, and we're going to put g of x. So again, I didn't have to do this piece right here. But because we're, just starting to learn what's happening here, is because this could be just sine of x, and x would still be a function in itself. But because x, the derivative of just x is 1, which means it doesn't change or do anything much to the function itself when we take the derivative. So this is what we're going to do. We're going to take the derivative of f at x, still using the chain rule. So this might not be a clear analogy, but I just wanted to see that this in itself is a function, and this in itself is a function. That's our g of x, okay? So the chain rule says we're taking the derivative of the outside function, which is the sine. The derivative of sine is cosine. We have looked at that. So this f prime at x, let's write here f, I think my marker is going. Let's write it orange. You got a new color here. F prime at x is equal to sine v, because v is what we have. We keep the inside function, which is v, g of x. See? And then the outside function, g prime of x, is equal to the derivative of x squared. That's the power rule coming into play. So when you get to derivatives that involves like the quotient and the product and the chain rule, you're going to realize that, hey, the power rule is also incorporated into it. So the derivative of this thing here, using the power rule on this, we take 2 down, the exponent 2 out front, we're multiplying that by 1, the coefficient here, and then we subtract 1 from the exponent, which brings us 1, so that's just x to the first power. We can leave it like that. So if we're going to write this thing now, if we're going to write this solution, so d by dx of this thing right here is equal to, we're going to look at this right here, f prime with g of x in it. So this is what? Sine of v. We say that v is x squared, right? Here we go. Well, wait. I made a mistake here. Here we go. It's just a cosine. Cosine. Again to people. Cosine of v. So this is the cosine. Cosine of x squared. Okay? Sorry about that. Now, we're multiplying that by the derivative of the inside function, which is 2x, which is the same as v, right? So 2x. So we bring that 2x right here. We could rewrite this, simplify it as 2x cos x squared. Done. Now, with some practice, after some time, you will just be looking at this and telling what the derivative is. Trust me. But it just takes practice. So, again, going forward, we're not always going to do this setup. Why I did this setup, I want you to understand what the notation here is saying. So you have a function within a function. We have sine function here and the x squared function here. That's a function within a function. And you have different cases. We're going to look at different cases where it's just only polynomials, all right? So remember, we have to take the derivative of the outside function. The derivative of sine is cosine. And we keep the inside function the same. That's what we have here. And we multiply that by the derivative of the inside function, which is x squared. The derivative of x squared is 2x. And I would have proved that in the previous video also. All right, let's move on. Let's look at a polynomial one right here. We have 2. Wait, where is it? Oh, down here. We have x squared plus 3 all squared. And I would have given an idea of this one in the previous video as well, right? So the outside function, if you look at it, the outside function is the squared part. The inside function is x squared plus 3. So if you're going to differentiate this, d by dx of this thing right here, d by dx of this thing, the outside function, let's say you make x squared plus 3 be u, right? Remember, if we let u equal x squared plus 3, then I could rewrite this thing as d by dx of u squared. That might show you the outside function a little bit clearer, right? Because u is a function of x, right? And we're going to take the derivative of u. So du on this side, let's just take du over here because we're going to be multiplying it by that. Du is equal to 2x, and that's it, because derivative of x squared is 2x, the derivative of a constant is 0. So that's just 2x plus 0. We don't have to put that 0 there. So that's du, okay? So what we're going to do now is we're going to differentiate this thing here. This is going to be equal to 2u, right? This is 2u, right? And that's just the outside function. We could consider that the f function. And the g of x is equal to u. And g prime of u is 2x. So now we have to multiply this. So it's like take the derivative of the outside, keep the inside. We multiply it by the derivative of the inside function, which is the derivative of u, right? And the derivative of u is 2x. So we multiply that by 2x. Good? And you might be wondering, hey, you got u and x, and we need it only to be a function of x. So again, remember we said that u is x squared plus 3. So we're going to rewrite this as 2, open parentheses, x squared plus 3 times 2x. And then we could multiply that by 2x. You're going to get equal, you're going to have 4x squared plus 3. And you could simplify that further. Or we could just go again. We're going to have 4x squared plus 12x. Done. Because 4x times x squared is x cubed. My bad. 4x cubed. And 4x times 3, 12x. Right? So that would be our final answer to this problem. Now, if I were to approach this, if I were looking at teaching someone and I wasn't to approach this, I would just look at this thing right here. I know my inside function. I see my outside function. I would take 2 down, out front, open parentheses. I keep the inside function. And then I multiply that by the derivative of the inside function, which is 2x, which brings me to the same result. We're going to have 4x, open parentheses, x squared plus 3. 4x times x squared, that's 4x cubed, plus 4x times 3 gives me 12x, just the same. So that's the chain rule in its entirety. You're finding the derivative of the outside and the inside function, and you're multiplying them like that. All right, let's move on. Let's use one more idea of this chain rule. And this time, we're not going to let anything. We're just going to do it from scratch. Let's get one. Nice. Here's one. Here's one. We have the tangent of 3x. You can ask yourself, hey, what's the outside function? This right here. Outside function. We're going to call that f at x, right? And inside function, g of x. Good? So inside function, g of x, outside function, f at x, right? So we're going to take the derivative of the outside and keep the inside, and then we're going to multiply that by the derivative of the inside function. Okay, all right, let's go. Let's go. So the derivative d by, so it's d by dx of tan 3x. So the derivative of tangent of x is secant squared x. So this is equal to secant squared 3x. But then we're multiplying that by the derivative of 3x, which is just 3, if you recall. That's raised to a power of 1. And when you subtract 1 from 1, you're going to get 0. So that x variable is gone. So now we multiply, we're going to have this 3 secant squared 3x. Done. Again, I do have the answer sheet to these. If I made any mistake, let me know in the comments. I won't check it. I promise you. I won't check it. Okay? Let's go. Next problem. We're going to look at a different, now we're going to look at the quotient rule, because I know that one, many students get confused with that one, the quotient rule. So we're going to look at that one. And let's look at the definition of the quotient rule. So it says f of x divided by g of x. So you're dividing functions. F of x divided by g of x. This is how you do it. For starters, what you can remember is that the denominator here will always be the denominator here, but squared. Good? So g of x squared. And I've used square bracket because I already had the parentheses right here. So, I mean, you could use the parentheses. Doesn't really matter. So the denominator squared. Good? And then up here, you're just using the chain rule with this thing. No, the product rule with this numerator and denominator thing. So you could start with the denominator here. You could say, okay, g of x times f prime at x. And then you're subtracting f at x times g prime at x. That's it. And you're done. So all you have to do is to take the derivative. This is the goal. When you get a quotient problem here, we could take the derivative of the numerator, take the derivative of the denominator, and you could square the denominator, and then you just plug those into the quotient rule here, and then done. You're done. You're finished. All right, let's go. Let's look at some of the problem. Let's get the quotient rule handout right here. quotient and product rule here. We get to the product rule in a short while. Let's look at the quotient rule that I have here. This is a nice one. H of x is equal to x over sine of x. Okay, this is a nice one here. Let's do that. So this numerator here is our f at x. We're going to make this f at x. And this denominator here is our g of x. In some books or some cases, you'll see them make this u and this v the same thing. And we could rewrite it like that as well. So let's just go. We're going to take the derivative of x, which is 1. So f prime at x, we're going to write that in orange on this side. So we're going to take f prime at x, meaning we're taking the derivative of f at x, which is equal to 1. We're taking the derivative of sine of x, which is g of x. So g prime of x is equal to the cosine of x. Good? And then also, remember, I told you we're going to take the denominator squared. So g of x all squared is equal to sine x all squared. See that? So these are the three pieces that we need. So you take the derivative of the numerator, the derivative of the denominator, and the square of the denominator. And that's what the quotient rule requires. So we're going to plug those pieces in now. So first, we're going to use red to do that. Oh no, let's use green. So g of x is what we started with. So it's the sine of x. So this d, let's get the derivative here. D by dx of x over sine of x is equal to, I'm going to write the answer, plug these things in green. So g of x, which is sine of x, we're multiplying that by the derivative, which is 1. So we'll multiply that by 1. And we're subtracting f at x. So we keep f at x now, which is x, times g prime of x, which is cosine x. And we're dividing that by g of x all squared, which is sine x squared. Sine x all squared. See that? And then we just clean this up. This is going to be equal to, we're going to write the final answer in orange right here. So sine of x times 1 is still sine of x. Good. X times cosine of x, that's just x cosine of x. So it's minus x cos x divided by sine x all squared. And we're done. We can leave it exactly like that. So just take a look at it. Remember, this is just for the starters. Going forward, we're just going to be looking at it and telling what the derivatives are, okay? So when you have a quotient, right, you take the derivative of the numerator, the derivative of the denominator, you could write that down, and then you take the square of the denominator. The quotient rule says you're taking g of x. So it's the product rule with subtraction. Earlier, I think I would have said it's a product rule in the numerator, and you would have think that that's sort of addition. But it's a product rule with a subtraction in the numerator. So if you remember it that way, that's some things like if you can derive things, you don't have to memorize them. And it's better to be able to derive them than to memorize. It works out. Because if you know that the quotient rule is similar to the product rule, but with subtraction in the numerator, and in the denominator, we have the denominator squared. That's it. You're done. All right. Let's move on to the next one. Where is the sheet? Right here. Okay. We're going to look at one more of the quotient rule. We're going to look at some polynomials. Let's look at this one. This one is nice. Log of x over x. We could do that one. Let's go. Where's the duster? Here. All right. Let's erase this piece. Okay, let's go. So we have h at x is equal to log x over x. This is a nice one too. All right, let's go. So we're going to approach this thing. Again, we have f at x and we have h of x. That's the only thing I'm going to label here because I'm using this notation. This is f at x and this is g of x. Good. Now, we would have looked at the derivatives of logarithmic functions. I did a YouTube video on this thing, logarithmic and exponential functions, where you look at the three-factor derivative. All right, and I'm just going to write that over that side. The log of base b of f at x. So we could write it like that because I want you to know that the argument here is a function of x or t or whatever you want it to be. This is equal to, you're going to take the derivative of the argument, which is f prime at x. You're going to multiply that by 1 over the natural log of the base, right? And you're multiplying that by also 1 over the original function. So that's how you remember it. So the derivative of the argument times 1 over the natural log of the base times 1 over the original function. And if you want to get a good idea of this, let's look at, for example, the natural log e, like ln x, like that. Natural log of x. So this is just log of base e, right? So that's what we're saying here. This is just log of base e. So we could rewrite this as log base e of x. Same thing. So if we do the derivative, we know that the derivative of ln x is 1 over x, right? Let's do the math and see if it works. So the derivative of the argument, the derivative of x is 1. So this is equal to 1 times 1 over the natural log of the base, which is ln e, times 1 over the original argument, which is x. As you can see the magic. 1 ln e is 1. That's log of base e of e. That's a property. So that's log of base e of e, right? When the base and the argument the same, that's log of 1. Because they're saying that, hey, what can I raise e to get e? You only can raise e to 1. So just doing a little refresh over that side. So what I'm about to do here doesn't confuse you, okay? So as you can see, we get 1 over x. For this one, to simplify, that's 1 times 1 over x, which is 1 over x. That's d by dx. So d by dx of ln x, right? And that's how we would go about it. So when you look at this now here, when you're not seeing a base here, that base here is 10, right? So you have base 10 right here. Good? So let's do the math now. Let's do the math. Let's do the math. So f prime at x for the numerator, notice this is equal to, we're going to take the derivative of the argument, which is 1. That's the derivative of x right here. We are going to multiply that by 1 over the natural log of the base. And this is again base 10. I told you that's ln 10. And we're multiplying that by 1 over the original function, which is 1 over x. So this just simplifies to, that's 1 over ln 10 or x. So that's just 1 over x ln 10. Good? And then the derivative of the denominator, g prime of x, is equal to, that's just 1. Supposed to be versed with this by now. So, and then we're going to square the denominator, g of x all squared is equal to x squared. Okay, let's plug that in now. So remember, this is the setup. So we're gonna plug that in and see what we have dealing with. So right here we have d by dx of h of x is equal to, we're going to take g of x first, which is x. We're multiplying that by f prime at x, which is 1 over x ln 10. And we're subtracting f at x, which is log of x, times g prime of x, which is 1. You know, 1 times anything if you want, but I'm still going to do that. And we're dividing that by g of x squared. G of x is x, so that's just x squared. That's why we squared that. And now let's clean this up. Let's clean this up, guys. Let's go. So he's green. So x times 1 over x ln 10, x cancels out. So it is 1 over ln 10. So that's 1 ln 10 minus log of x times 1. That's just log of x. So that's just log of x divided by x squared. I mean, as a good mathematician, we should be able to clean this up thing. Let's clean this up. Let's clean this up, guys. All right. To do this, what we could do, we don't want to go into change of base here because this is base 10 and this is base e, right? We could change this to base e if we want. But I mean, we could leave it like this. This is b over 1. We could solve that. I'm going to leave it like this for now because, I mean, it takes too much time to solve that. We're going to have to change that to base e. To change that to base e, we'll have log base e of x divided by log base e of 10, right? And then that's a change of base formula for this one here. So this equivalent to this piece right here. And then we would go ahead. This is at base e of 10. Hey, it's the same denominator. It works out nicely, right? All right, we could do it quickly. I didn't see that it works out nicely because then this is base e of 10. That's ln e. Okay, let's go. So this is just equal to, in the numerator, we will have 1 minus log base e of x divided by log base e of 10. There we go. And we're dividing that by all of that by x squared, which is the same as multiplying that by 1 over x squared, right? So in reality, our final answer would be equal to 1 minus log base e of x all over x squared log e 10. Nice. See that? And I mean, we could change that 1 to a log as well, because we could say log of base e of e, right? You could do that. And then use properties of log to, this could go way further. Well, we're going to leave it right there. Right there, we're going to leave this thing right here. Right here. Good? Because I don't know, I don't even think the answer solution would have simplified it either way. So again, what we did here, we got to this, but I did not see that this simplifies nicely because this is log of base e of 10. And if we change a base here and make this thing right here base e, we're going to have log of base e of x over log of 10, and that's why it simplifies to this. And we multiply that by 1 over x squared, because dividing by x squared is the same as multiplying by its inverse, like that. And then we simplified. X squared times this gives us that. And hopefully we didn't make any mistake with that one. All right, let's look at the product rule quickly, guys. Let's look at the product rule real quickly. Let's get in at least 2 examples of the product rule, and we're gonna close out. Let's go. hope you guys are seeing that too. All right, so we're going to look at the product rule real quick. And the product rule says that if you have f at x times g of x, that's just equal to f prime x g of x plus f at x g prime of x. There we go. So you take the derivative of the first function, multiply it by the second, plus leave the first function and take the multiply that by the derivative of the second. Good. And we're going to look at a quick example of the product rule. We're going to look at two actually. Let's look at this one right here. X squared sine 2x. I mean, we've been using sine and the other one. We're going to use tangent afterwards. So we're going to say d by dx of this thing right here. So notice you can see the two functions. That's what the product rule is. It's easy to see. You could say this is f of x and this is g of x. So this is just equal to, let me highlight that. So this, I want this to be my f at x, and I want this to be my g of x. So I just need f prime at x equals, I'm taking the derivative of this, the power rule comes into play. We take the exponent down times the coefficient out front, and then we reduce 1 from the exponent, 2 minus 1, that's just 1. We're going to leave it like that. Then this one here, wow, you see that? You see what's happening here? We got the chain rule right here, because that's a function within a function. So we're going to use the chain rule here to find the derivative of that one. So this one here, or g of x, g prime of x is equal to, so the chain rule says you take the derivative of the outside function. So the derivative of sine of x is cos of x, so that's cos of 2x. And then we're multiplying that by the derivative of the inside function, and right here, again, power rule, or you could just say the derivative of 2x is just 2, so times that by 2. So this is equal to 2 cos 2x, just like that. And now we could go ahead and use this thing right here to find the solution of this thing. So this is equal to, let's put that in orange. Let's go. So d by dx, this is equal to, we're going to take the derivative of the first one, which is 2x. We're multiplying that by the derivative, the original function g of x. So that's 2x sine 2x. And we're adding to that, we're keeping the first function g of x, x squared. And we're multiplying that by the derivative of the second function here, g of x, which is 2 cos x, 2 cos 2x. All right? Let's clean this up a bit. We'll put the multiplication sign here. Let's clean this up. So we're going to have this equal to 2x sine 2x plus 2x squared cos 2x. Right? And if we take out the 2x out front, you can see we could factor 2x out. We're going to have 2x outside the parentheses. Let's just do that quickly. We're going to have 2x open parentheses sine 2x plus x cos 2x. Done. Again, type in the comments and you could type a question that you would want me to solve using any one of these properties of our rules in differentiation. Let's go to the next one quickly. We're going to close out. I think this video is awfully long. Probably not so long as the ones that I made before. So we're going to look at the x tangent of x. So d by dx of this thing here. All right. And again here, we can make this here f at x and this here or g of x. So let's use the power rule to differentiate. So because, again, we're beginners, we're learning, I'm going to just say, hey, f prime at x, that's the derivative of the f of x, which is x is just 1. Good? And g of x, g prime at x, that's the derivative of g of x. And that's a chain rule again, but because the derivative of x is just 1, it doesn't seem like it, but I'm going to use it to show you. So the derivative of the outside function, The derivative of tangent of x is secant squared x. So we derivative of the outside and we keep the inside function just the same. And we're multiplying that by the derivative of the inside function. And the derivative of x is 1. So that is why 1 times that is just secant squared x. So we don't have to put that right there. Okay? So let's plug that in now. So this will be equal to, let's get the orange. So this will be equal to, we're taking the derivative of the first function, which is 1. So we have 1 times, we're keeping the second function the same, tangent of x, plus, we keep the first function, which is x, times the derivative of the second function, which is this one right here, secant squared of x. And then we could just clean that up. Let's clean that up nicely. 1 times tangent of x is just tangent of x, plus x times secant squared x is just x secant squared x. And we are done. I hope you guys enjoyed that video. And again, if you have any question that you would like me to solve using any one of these differentiation rules, you could type that in the chat and I will see if we could do another video on that for you guys. If there is any question, put that in the comments again. Please like, share, subscribe. I need the support. You know, tell a friend to tell a friend. I'll see you guys on the next video.